Hello and welcome back to another episode of Maths with Machine Learning. Maths in Machine Learning, to be honest, yeah. So this is the second episode. In the first episode, we briefly went over what are the things that are required for maths, or for generally in the roadmap of learning machine learning and data science. And today we are starting with the mathematics part. And the first part of mathematics is statistics and probability. So we're going to start today with statistics. Statistics is a core component of data analytics and machine learning. It helps you to analyze and visualize data to find unseen patterns. But regarding this, let's learn what exactly do we mean by statistics. Statistics is a branch of mathematics that deals with collecting, interpreting, analyzing, and visualizing the data. In very simple terms, what does statistics mean? It just says that you collect the data, you analyze the data, you interpret the data, and then visualize the data in simple terms. There are two types of statistics. One is one is descriptive, and second is inferential. Stats. So what do you mean by descriptive? Descriptive statistics summarizes and organizes the characteristics of a data set. It basically describes the data set. And inferential statistics is a branch of statistics that deals with the various analytical tools to draw inferences based on the population. As the name suggests, it infers the data set. So today we'll learn more about descriptive statistics. And when you start learning descriptive statistics, the main thing that you learn are the measures of central tendency. The measures of central tendency. So what do I mean by measures of central tendency? The measures of central tendency are a statistic that represents the mid value or the central value of a large numerical data set. It represents the mid value or the central value of the data set. Now, you may have heard about the terms mean, median, and mode, right? So these three are the measures of central tendency. Mean, or the average value, describes the average of the total data set. So let's say if you have a data set of the height of a class, let's say 150, 157, 158, 172, 165, 196. So we have 1, 2, 3, 4, 5, 6. So if you add this total x, the sum, and then divide by 6, you will get a median height. Now what does the mean height, the mean or the average height? So this is what the mean is. The median is the centralmost value. So in this case, how do you find a median? You find a median by rearranging the data set in ascending order and then find the middlemost value. That's how you find mean. So that's how you find median. So the mean is the average of the total data set. Median is the middlemost value of the data set. Now coming on to mode. What is mode? Mode is the value that has the most frequency / occurrence in the data set. Are we clear about this? So the mean is the average value, median is the middlemost value, and mode is the value that is occurring most in the data set. This is the basic template or definition of these three that you can give. Now coming on to the math part. Yeah. So let's start with mean. As you all know, the mean is the arithmetic average of a set of numbers and it is calculated by summing all the values in the data set and then dividing by the count of the data set. So let's see in the formula. Mean, which is denoted by the mu symbol, is the summation of I from 1 to n of all the x data points divided by the total number of data points in the set. This is how you find mean of a data set, where xi is the individual value of the data set, and n is the total number of values in the given set. Now let's see, why do we use mean, or let's see the advantages of using mean. First, it is very easy to calculate. Second, it uses all the data points. So why the second point is useful is because it reduces the skewness of the data. We will come to the skewness and the terms later on this series, but it's very essential to keep this in mind, that all these statistics or all these things that we are learning is just the backhand part of the code. You will never be asked to calculate the mean by using hand method. You'll always use the sklearn library or the numpy library to calculate the mean, np.mean. So that's not really a big issue when you're coding in terms of coding, but you need to know why you're using this thing. Like if someone asks you, then if someone asks that why did you use np.mean in your code, so you should know that we are using mean. np.mean is calculating the average of the all total points, and you should know that why you're using the mean and why not other methods of central measures. So just the advantages, we need to keep clear about the advantages. Also the disadvantages. The disadvantage of using mean is it is sensitive to outliers. It is sensitive to outliers. We will learn about this term outliers also in the coming videos, and the skewness of the thing. Now moving on. So this is what mean is. Mean is the arithmetic average of the total data set, and this is how you calculate the mean. Moving on to the median part. Median is the middle value of the data set. Okay, sorry, I forgot to teach you about the population and the sample. So after we're done with the central measures, we'll just get a quick go through of what is population and what is sample. Okay, so that's probably why the dataset thing would be confusing to you right now, but we'll go through it. So the median is the middlemost value of the dataset, and to get it, to get the middlemost value, we arrange the dataset in an ascending order. So as we saw in mean, we do not need to arrange mean in ascending or descending order, because mean just calculates every point, every data set's average. So if you have, if for example that we gave here, yeah, if we have 150, 157, 158, 172, 196 and 165, it could be arranged in any order, but it would not change the average of the data set. But in median, you need the middlemost value, and so we need to arrange it in ascending order to get the middlemost value. So it depends on how we arrange the data set to get the mean or to get the median. Now in mean, there's only a single formula to calculate mean, irrespective of whether it's even numbers in the data set or odd numbers in the data set, because it doesn't matter, we are dividing it by the n, which is the total number of values in the data set. But here in median, it is really important to keep in check if it's even or odd, which is the total number of data points, total number of observation or total number of data points, total number of data points. Suppose if it's odd, let's say we are calculating 1, 2, 3, 4, 5. If you're getting this is the total count is 5, which is odd, right? So if we have this kind of data set, the middlemost value is the third value, or if you use the formula, it's n by 2, right? What did I say? Oh yeah, sorry. I was saying in the terms of Python code. So how do you get the middlemost value in Python? Is that you divide it by the total number of things using double this and then 2. So it will give you the whole number. So if it's 2.5, it will go back to 3. That's why I got confused. Yeah. So that's how you do this. That is in the odd one. In even one, suppose 1, 2, 3, 4, 5, 6. You have to add the two middlemost values. So it's 3 plus 4 divided by 2, which you get 7 by 2, which is 3.5. This is the middlemost value in even terms. So let's look at the advantages. So you know how to calculate this, right? You get the middlemost term. In odd, the single term is the middlemost term, and even you have to average the two middlemost terms. This line, okay. Sorry, my bad. Yeah. Okay. Now let's move on to the advantages and disadvantages of using median. Advantages is it is not affected. Wait, let me read this part. This part as well. It is not affected by the skewness of the data. Second is it represents the central value. Disadvantages are it does not use all the values. Yeah, so let us look in this thing. We have 1, 2, 3, 4, 5, but we are only using 3. And in even, we have 1, 2, 3, 4, 5, 6, we're only using 3 and 4. So it does not include every data point, it just includes the centralmost data point. Second, it can be less informative for small data set that have repeated values. Moving on to third and the final thing of measures of central tendency, that is mode. The mode is again the most frequent value / observation occurring in the data set. This is very self-explanatory, and when you compare with mean and median, it doesn't have any formula. Just see which is the most recurrent data in the data set. Suppose, for example, again we're taking the example of the height in a class. So let's say it's 150, 172, 173, 174, 190, 174, 182. These are the few people in the classroom. So you can see 174 appears twice in this list, in this data set. So we can say the 172 is the most frequent data point in the whole set, and then mode is 172 for this particular data set. So when the mode is important, so all these things you will need to know when you're calculating, not calculating, but when you're pre-processing the data. So when you're pre-processing the data, there's a segment called null values, or values that don't make sense in the data set. Suppose you have, what do you say? Let's take example of a salary data set, salary of a company. You have the name, department, employee ID, date of joining, and years of experience. When do you need these things? Suppose you don't have and a salary, of course. Suppose suppose you don't know. So the salary is here. You have thousands of data in this whole spreadsheet, but there are few columns of salary, few cells of salary that are not filled. So you need to fill it for accurate data, right? So what do? You calculate the average of all the data sets and then use that average to fill this cell, these cells. This is the one way that how you pre-process the data. That's how you use mean. The mode is the most frequent data point in the data set. So where would you use? Suppose you have department wise, there are HR departments, tech department, executive department. Suppose there are a lot of tech department. Out of 1,000 people in this data set, suppose 700 people are from tech department, and 150 people are from HR department, and around approx 50 people are from executive department. So we total got 900 people right now, but we need 1,000 people. So that means 100 people's data is missing in this row. So what do we do now? How do we fill the data? We cannot use mean here because it's not a numerical value. So remember, mean only works when there is a numerical value. Yeah, it only works when there is a numerical value. So here what we will do, we can take the mode. We will fill all this remaining 100 people with the most recurrent thing, that is the tech department. This is how generally you will use all the measure central tendency. That's in short of how statistics is important in data science and machine learning. Just as a small gist, it's a very vast subject, and I know I'm not an expert of this subject. I'm trying my best to give a good example so that you will know what really is the use of all these things, of measures of central tendency, of mean, median, mode, and how you will use in a practical scenario. I think this is it for then. Oh yeah, I need to, yeah. So the main thing in statistics are these two terms, which are population and sample. Population, as the name suggests, is a set. Oh, sorry, I think, yeah. Oh. What? Why? Population is a set of / collection of all the data points, and sample is a subset of population. So for example, you have a country named A, and the country has million people, and you want to conduct a survey. for country A to see what is the sentiment of the people, of the population in regard with a certain bill. You don't have the resources or the time to conduct a survey for 1 million people, right? So what would you do? You will get a sample size, sample of the population. That means you will choose, let's say, 10,000 people out of those 1 million people to conduct survey, which is economically more effective than to conduct 1 million people, survey 1 million people. In these 10,000 people, you can conduct the sentiment analysis of the bill that is gonna pass, and from that sample size of 10,000 people, let's say 80% people are happy with the bill and 20% are not satisfied. You can pretty confidently say that if this was set for the whole country, the 1 million people that live in the country, it would approximately be equal to the sample. So that's why sample is very useful when it comes to the bigger population, because you cannot always go for the population and ask them to fill survey forms. I think this is it for today's episode. So today we covered the basics of statistics, the descriptive statistics, inferential statistics. We covered the descriptive statistics parts of the measures of central tendency, which are mean, median and mode. Mean is the average of the class, median is the middlemost value of the class, and mode is the most recurrent value of the class. Here's a formula how to calculate mean, its advantages and disadvantages. Then we see what is median. As I said earlier, the median is the middlemost value of the data set. And in this case, we have to arrange the data set in ascending or descending order. That's up to you, how you arrange it. And it is really important to note that the data points, the total number of data points, are they even or they odd? Because if they're even, the formula is different to calculate the median, and if it's odd, the formula is little different to calculate the median of the data set. Then we see the advantages and disadvantages of median. And then finally we come to mode, which is the most frequent or recurrent value in the data set. And we just saw a small demo of how these things actually work in a real data set. And then which I should have done earlier, the population sample, we learn about population sample, which is the set of all data points, and sample is a subset of population. And I think this is the end of today's episode. Next episode, I'll cover more about the interquartile ranges, quartile ranges, normal distributions, and all the probability distributions. So yeah, see you in the next episode. Thank you.